go counterclockwise, correct? Negative rotational angles go clockwise. And they can be coterminal to each other, right? A negative rotational angle can terminate on the same spot as a positive rotational angle. So we did do that. And we were here. So here it says sketch the following rotational angles and give the reference angle and give two coterminal angles. So we'll go sketch them. You guys should have them sketched in front of your faces. I just didn't do the whole question with you. All right. So if we do 60, we would have to have 0, 90. We'll have some of this already. That's totally fine. 180, 270, 360. And I need 60. So I draw my initial arm. I draw my rotation, which is this dot, and then I have 60. Draw my arrow and put 60 degrees. True statement? Reference angles are what? Yes, the angle to the x-axis. So it's the bow tie angles. Remember how I talked about bow tie angles? If you draw your angles, it's the ones that would be connected to make a bow tie. So it's always the angles between the x-axis and the terminating arm. We agree? So in quadrant 1, what could you say about the reference angle and the angle? They're always the same, correct? The reference angle is the bow tie angle, and the angle is the bow tie angle, correct? So in quadrant 1, your reference angle and your angle are always equivalent. So I'm going to go reference angle equals 60 degrees. Less. Okay. There is one highlight in life about radian measure. One. There are numerous ones I like radians, but for you, the only thing I can find that you're like, yes, that's awesome, is this one thing. The reference angle of a radian measure is the easiest thing to find. It's always pi over whatever the heck the denominator is. So for the next one, it's 5 pi over 3. Remember, reference angles have to be between 0 and 90, or 0 and pi over 2, because it has to be an acute angle. It's an acute little bow tie angle. So if we do 5 pi over 3, a lot of you guys converted this. So we went 180 degrees over pi. And what did we get? You did do this. I know you did. 300. All right. So then I can do this, right? 0, 90, 180. Can I do that? Because you like degrees doesn't mean the question was in degrees. You can't be like, I hate radians. I just can't get rid of it. I'm just going to degree it up. If you do that, cool, you're going to get no marks. Because it was asked in what? Radians. So if the question is asked in radians, you have to do it in radians. Now, could you convert it to degrees so it's a little more common sense for you right now at this very moment when you don't know radians very well? Sure. Could you do the whole unit? Sure. But when you draw it, you are going to have to put the arms in radians, and you're going to have to draw it and put the angle in radians. Okay? So you guys should have that already in front of you. 0, pi over 2 is 90, pi is 180, 3 pi over 2 is 270, and then 2 pi. So I know it's 300. I know I have an initial arm. I know it's positive, so it has to go counterclockwise. 300 is what? Is 60 less, so it's going to go like this. Okay? And then I'm going to put 5 pi over 3 here. I am not going to put 300. There are a ton of people who do poorly on the test because everything was in degrees. You can't do that. If it was in radians, your answer and all of it needs to be in radians, okay? You can convert to help yourself out, but the whole thing still needs to be in radians. All right. I know it's 60 degrees away, and 60 degrees is pi over 3 in radians, and you convert it. But the greatest thing, so reference angle. The greatest thing about radian measure is the reference angle is pi over whatever the heck the denominator was, it's 3, which is 60 degrees. So radian reference angles are really easy. Pi over whatever the denominator is. There's your one highlight. Okay, here we have negative 2 pi over 3. Even if I don't draw it, what's my reference angle? Pi over 3. Reference angles are acute positive angles, so you wouldn't put negative pi over 3. It's still whatever the heck that angle is between the arm and the terminating arm. So I know this is going to be 60 away as well. Well, let's convert it if we'd like to, which we already did on that Friday. Negative 2 pi over 3 times 180 degrees over pi. And we got negative 120 degrees. We agree? Can't do this in degrees though, still, even if I like that. So I'd have to 0, negative pi over 2 is 90, negative pi is 180, negative 3 pi over 2, negative 2 pi. And I need 120, which is 60 away from 180. Draw my initial, draw my terminating, and draw my arrow this way because it needs to be going that way because it's counterclockwise, or it's clockwise because it's negative. Yeah? And then we go negative 2 pi over 3, not negative 120 degrees, because that's not what it asks. Well, I know if that's 120, it's a reference angle of 60, correct? And 60 is pi over 3, but we already have that because radians reference angles are nice. All right? Then we go to 300. We already did formula. Okay, 300 is here. Here, angle. Make sure your arrow's showing which way you're going. 300 degrees, and then I do need to label stuff. You guys should have this done already. What is my reference angle? What's that little bow tie angle between the terminating arm and the x-axis? 60. So from here to here is 60. We already did it here. And here, we've done it in a lot of ones. This one was 62. It was actually 300. So the reference angle is pi over 3, correct? Say no. What is it? 60 degrees. Because the question was in degrees. Reference angle needs to be in degrees. I draw it in degrees. All my answers are in degrees. Yeah? All right. Negative 135. 0. Negative 90 degrees. Negative 180 degrees. Check and make sure you have degree symbols. If you don't have degree symbols, what happens? It's in radians, which is wrong. Hola, senor. All right. Okay. So we're at 135. Negative. What is the reference angle, guys? How far is it from this terminating arm to the x-axis? How much? 45. So my reference angle is 45 degrees. And then I have 750. So we went over this. This would be 360, 720, plus an extra 30. Arrow. 750 degrees. So if it takes me 720 to get to this arm, how much does it take me to get to the actual terminating arm? Or to get to the x-axis? How much to the terminating arm? 30. So it's a reference angle of 30. Okay, coterminal angles we talked about a little bit. Coterminal angles terminate on the same arm, correct? Hence coterminal. So, I want you, as a team, together. Maybe a little tiny calculator. That was a phone. I was a little sus, but it's just that calculator. The other one's charging, it's totally fine. He's a strong word. All right. As a team, I'm going to give you 120 degrees. I want you to give me two angles, a positive and a negative, that would terminate on there. Two other angles. And I'm not telling you how. Go. Okay, let's talk about this. So, are there only two coterminal angles with this angle? Are there only 4? 6? How many? There's infinite. So there's an infinite number of coterminal angles that work with this angle, yes? Unless I restrict your domain, which is what we're going to end up doing. So we'll end up restricting your domain. It might be between 0 and 720 degrees. And then you would give me the one other coterminal that would work, correct? Or I might go negative 360 degrees to 0, and then you would give me the negative that you found. Yes? If I don't restrict it, we're going to have to do general form, which is what we're going to do next. But for right now, we're going to restrict. So if I need it to land on that same arm, if I draw 120 degrees, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360, and I have 120, which is here. And I need it to terminate on there. I need to land back on. What can I do? Add or subtract 360 degrees, because 360 degrees is a full what? Full circle, full rotation, and it'll rotate it right back on. Yes? So, 120 degrees, guys, quiet please, plus 360 degrees equals 480. You wouldn't have had to give me 480 degrees though, correct? You could have added another 360 to that, another 360 to that, and then a rebel. And give me whatever that is, correct? So instead of adding 360, you could add 720, which would be 2 rotations, right? You wouldn't have to go 360 plus 360, you could just add 720, which would be 2 rotations, yeah? Okay, then we went in a negative direction, which means we'd subtract 360, which is negative 240. Okay, if I want a positive and a negative coterminal angle, cool, that's the answer, yeah? But that's the answer to 2 coterminal angles. Like I said, if I restricted the domain, you could get one or you could get the other, correct? If I restricted the domain from negative 360 to 720, you could both answers, yes? And an angle itself is coterminal with itself, so actually 120 is coterminal with itself. However, that was going to be another. Now, how could I give, this we're going to lose people, is in the general form, so paying close attention, because like you'll be lost in Narnia, like you don't even know where you are. Okay. Narnia is real, it's in my closet. It's not. All right. There's a closet back. Okay. All right. Okay. So let's talk about this in general form, because I want you to understand why general form works, not memorize it. So you memorize it, and they change the general form up a little bit, you're in trouble. Understanding over memorization, yes? Memorization only gets you so far. So, if I say theta equals, and I start off with 120 degrees, what did you do to get a coterminal? You added 360, then you added 720, then you keep going, correct? Or you could subtract 360, subtract 720, and keep going. Do you agree? Yes. So how the heck can we write this out? Everyone paying attention? They only use a plus sign. They don't use a subtraction sign. So watch this. We go plus 360 degrees, correct? Everyone's paying attention? That would get 1 coterminal, correct? If I add 720, that would get me 2. 1008, keep going, go, 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 right? They don't use subtraction signs. They only use a plus sign in general form. Back in the old curriculum, it used to be plus or minus, but it's not anymore. It's always a plus. Okay. Then they put an n back here. N being a variable. We need a variable because I'm going to add 360, or I'm going to add 720, or I'm going to add negative 360, or I'm going to add negative 720, correct? So that n represents something. I have to figure out what the heck the n represents. So if I go 120 plus 360 n, what numbers could I put in there? What would you put? I could put a 1. Cool. What else could I put? Negative 1. I could put a 2. What else could I put? Negative 2.
You could put 6,000.
You could put 6,000. What else could you do? 0. If you do 0, what do you get? 120, which is still coterminal, yeah. Could I put decimals? Would decimals get me? No. So what am I talking about here? What do I need? Whole numbers is true, but I also need a little more. Integers. Whole numbers are the number of the whole plus ones you add, like from a little on. So natural numbers are the natural numbers you count as a child. I don't see any little toddlers going 0, 1, 2, 3. They go with the 1, 2, 3. Natural numbers are the natural ones you count. Whole numbers are the natural numbers plus 1 with a whole, 0. Integers is when your life became a lot different because you realized there was negatives in the world and life got a little rough for a little while. So you're telling me, guys, you're telling me n has to be what? It has to be an integer, correct? Do you all agree with that statement? Yes. So then I have to follow behind with n has to be an element of the integers. If you put reals, then you're allowing decimals. If I multiply by 2.5, is it going to land on that arm? No, it's not. So you see why it's an integer and not a real number, which is a whole bunch of input? Understand, not memorize. Trust me, it will make your life a lot better. Memorizing scares me. Because sometimes you memorize wrong. Or stress memorization means you just fall out when you get stressed. Does that make sense? Okay, let's do a little talky talk. What if it's not degrees? What if it's radians? No, radians is equally as easy, if not easier. I'm telling you. So, 120 degrees, what is that in radians? 2 pi over 3. Yeah, you can convert it. It's fine. So I'm going to go 2 pi over 3. Okay? Everyone's paying attention? When you do the general form, you'll always do the principal angle plus whatever. So if I had given you, instead of 120, say I had given you negative 240. If you were taking the general coterminal, you still would have to find the principal angle, the one between 0 and 360, which would be 120, and then add. So your general form is always principal angles, the one between 0 and 360, plus 360 degrees as NEI. Okay? So had I given you negative 240, or I had given you 480, you would still have to find 120 and then still get this general term. So your general term is not going to be different if I give you a coterminal that's out of 0 and 360. Because you're still going to find that principal angle between 0 and 360 first, then state your general term. Okay? So, 2 pi over 3, cool. If I go to sketch it to help myself out, 2 pi over 3 would be 0, pi over 2. I don't get to put degrees here just because I don't like radians. Math doesn't care what you like. You have to do it the way it is. So, we're still here, we're still here, we're still here, we're still here, we're still 2 pi over 3. I want you to give me a positive and negative coterminal goal. Could I convert that to degrees, add 360, the exact same one as previous, just so you know, and convert it back to radians? I could, which is what some of you do. However, you're adding 360 degrees to a degree, yes? So to a radian, do you have to change it and then convert and add it to 360? Or what could we add to it? 2 pi, yes? So I could go 2 pi over 3 plus 2 pi, if that's Mr. Clay's maps, just in case you're wondering. It took me about a year to figure out what that was. It's when he puts maps down and releases maps. Social maps. Maps. Geographical maps. Okay. So, guys, if you type this into your calculator, I would suggest you do it mathematically, which we're going to do. But if you do type it into your calculator, what can you not put in? Pi. So if you put the pi in, no matter how hard you hit math enter, no matter how aggressively you hit it, no matter how mad you are and you tell me it doesn't work, it won't work. Because pi is a non-repeating, non-terminating decimal, yes? So it will never convert back to a fraction. So if you're putting them in, you would have to go 2 over 3 plus 2, and then convert that, put the pi back in. That's the only way you can do it. Also hazarding you to use the fraction button. If you don't use the fraction button to actually put in a fraction, or you don't have it to a TIV3, fraction should always go in what? Brackets. That's what your calculator knows to do it first. What does your calculator always do? What's the most consistent thing that calculator will do? Order of operations. Yes? That calculator is programmed to do bed math. So if you wanted to do a fraction, you put it in brackets, it's going to have to do that first, because it will do bed math. Yes? That is what the calculator is programmed to do. So 2 over 3 plus 2 pi, we could go 2 over 3. How do I have to make it a common denominator? So I have to multiply this by 3 and the bottom by 3. So I'm going to get 6 pi over 3. So it is 8 pi over 3. Then I have 2 pi over 3 minus 2 pi. I times that by 3, times that by 3. And I get 2 pi over 3 minus 6 pi over 3, which is negative 4 pi over 3. Is the general form hard? Way harder than the degree one? No. You do have to still add what to it, though? What gets it to land back on top of it? What do you have to do to a radian measure to get it to land back on top of it? What are you adding to it? 2 pi, correct? So I get a ton of people on a test going, theta equals 2 pi over 3 plus 360 degrees n. I'm like, no, you have like a mixture. You can't do that, right? If it's in radians, you have to add what to it? 2 pi. If you just add 2 pi, you're only finding the first positive coterminal, correct?
So if I want to find all of them, the infinite number of them, all of them in the world, I have to go 2 pi what? N. Now sometimes on a diploma they write N 2 pi, or they'll write 2N pi. Does that change it? 2 pi N. 2N pi. Pi N 2. That looks really stupid, but if they could do that. It's multiplication. Multiplication's commutative property of multiplication means you can move anything around and it means same thing. Yes? So I get people who are like, 2 pi n, they put 2n pi. It is dip. No, it's not. 3 times 2 times 4, 4 times 3 times 2. Same answer. Same thing. Okay? And then what do I follow behind with? N is an element of the real numbers. That would include decimals. Can I include decimals? No. So they have to be, this has to be the number 1, 2, 3, -1, -2, -3, correct? So n has to be an element of the what? Integer. Cool, I'm glad we had this discussion. Go back to the page you had with 6 graphs on it. If you're still on that page, yay. You never left it, you believed in it, you wanted to stick with it. I want you, paying attention, I want the first positive and first negative around this one, coterminals. I want 2 of them for each of the 6, and then look down here. Determine the general form for the number 5 above, okay? Then we're going to go through the answers. So I want a coterminal, positive, negative, around each of these 6, and then I want 2 of them, and then I want you to do the general form, okay? Go. So the first one is in degrees. My coterminal angles would be theta equals 60 plus 360 degrees. Make sure you have degree symbols on your page. Don't be the person who loses all the marks because it looks like you're doing radians and then get mad at me because I messed up. Obviously, you know it's degrees. No, I obviously don't. There's no degrees. Okay? Don't go talking to me like that. I'll be like, girl, no, please. Okay. So, theta equals 420 degrees, and I'll talk to you like that. I'll be like, Or you like, and I love it because whatever people feed me, I just like, this sucks. I'm like, yeah, it does. You're doing something wrong. I'm like, what am I doing wrong? I'm like, it's a test. Can't you tell me? No. And you just I just aggress. I just do what you do. Back. It's fun. And then it, like people are like, what's going on with her? I'm like, how do you do? And then it's over. No. All right. And then our next one is 60 degrees minus 360 degrees. What do we get? Negative 300. Okay. I gave you the principal angle. True statement? Yes. Principal angle is the angle from 0 to 360. Yes? So that sets you up really good for the general form. 60 is what it is. So I'm going to go down here. And I'm going to say theta equals. Okay? You have to say theta equals or you're not actually giving an angle. Correct? Theta equals my principal angle. So it's 60 degrees. Plus, what do I need to do to get it to rotate fully around? 360 degrees. And what do I have to put behind it? An N. Now, for those of you who are still like, I have no idea why we do this. Okay, if I have 60 degrees plus 360 degrees, N. And N was an element of the integers. N could be 0, correct? So if I went 60 plus 360 degrees times 0, I'm going to get 60, yes? If I go 60 plus 360 degrees, I use my next positive integer via 1. Oh, I'm just adding 360. If I do a 2, I'm now adding what? 720. If I do a 3, I'm now adding what? 1080. If I do negative 1, I'm now adding what? Negative 360. So that's how you subtract. Yes? When you add a negative, that's a subtraction. You see why we're doing n as an element of the integers? Because the integers makes you add and subtract. Yeah? All right. Back to the drawing board. I have to follow behind with n as an element of the integers. Okay. I'm going to do E next. So if I do negative 135 degrees, I have to write coterminal. If you don't write coterminal angles, do they know you're finding coterminal angles? No. So negative 135 plus 360 degrees, what do I get? 225. If I do negative 135 minus 360, I get negative 495. Correct? I picked this one specifically because we're still in degrees. Yes? People like living in degrees. Eventually you won't mind radians, but right now most of you don't like it. I might be wrong. But I've been here before, once or twice, or I think 47 times. I don't know. At least 4 times a year times 2012 to 13. You do math. Okay. All right. Ready? So that's E. What do I use for my first angle? Negative 135. We discussed this. Would I use negative 135 in my general form? No, I have to use my principal angle. My first positive angle between 0 and 360. So I can't use negative 135. What would I have to use? 225. This one. Plus 360 degrees, N. N is an L in the integer. Then, I'm going to go up and use 5 pi over 3. So if you do 5 pi over 3, you'd add 2 pi, you'd subtract 2 pi. You have to make a common denominator. So I go 5 pi over 3 plus 6 pi over 3, which is 11 pi over 3. Or 5 pi over 3 minus 2 pi. Remember, you can put it into your calculator, just can't use the pi's. So it'd be 5 pi over 3 minus 6 pi over 3, which is negative pi over 3, which makes sense because that's negative 60. If I went like that, that would be negative 60. It would land on it, correct? What angle do I have to use for my general form? Leave, I go get a drink. What general form would I have to use for my initial? Pi over what? Pi over something, or 5 pi over something, or 5 pi over 3, because that's the principal angle. So I'm going to go theta equals 5 pi over 3 plus what? 360 degrees N, NEI? No, what? 2 pi N or 2N pi, it doesn't really matter, they're all the same. And then, N is an element of the integers. Okay, I want everyone to have their formula sheet out. If you don't have it out, you should have it out from now till the end of eternity, or at least this semester. Okay. Here's where your life has been ultimately changed. This moment in time. You're welcome. So, let's think about this. Our calculator till now, your teacher would have said, okay, we're resetting it. Now, everyone, make sure that you put it back to degrees or you're going to be in trouble. They can do that in physics 20. The default's to radians because the world actually makes sense in radians and not in degrees. All word problems in trig have to be in radians. Because you'll rotate, let's say you'll rotate around the Ferris wheel in 30 seconds, right? That's radian measure. It's not rotating in 30 degrees. You're rotating in 30 seconds. So every word problem in trig is actually in radians. So, cool fun fact. Your calculator can be in radians or it can be in degrees. When it resets itself in radians. Cool. Everyone paying attention to me right now. Because I hate this question over and over and over. It actually kind of makes me giggle eventually because I'm like, what are you guys listening to? Not me. That's what you're not listening to. Your calculator is a wonderful little device. Quite expensive. It's worth every penny. Now, listening. You'll be in polynomials and you're like, this stuff doesn't need to be in radians or degrees. And then I kind of giggle because I'm like, you didn't listen. Silly, silly beings. All right. It only matters if it's in radians or degrees if you're doing trig. We agree? There are 3 buttons on this calculator where radians and degrees matters. If you are not touching those 3 buttons, they don't matter. All right? The sine, the cosine, and the tangent button. Or the second sine, second cos, second tangent button, which would be for angles. Correct? If you touch those three buttons at any point in time, before you touch the button, slap your hand and be like, radians or degrees, girl, radians or degrees. Okay? Oh, no. Second sign ain't so bad, okay? All right. So, if I watch this, I want you to tell me if it matters. Are you guys ready? Okay, cool. Listen, I'm going to type in y equals. Does it matter currently? Okay, now you're just listening. You're going to tell me 2x cubed, okay, plus 4x squared, plus 7x minus 1, plus cos. Oh my God! That's it. That's all it is. If you press those three buttons, figure out what you need to be in. If you don't press those three buttons, do not call me over and say, Mrs. Lepp, what does this have? Does it have to be in radians? Do not do that to me. Please. We've had the discussion. You're all here today. I took attendance. Cos, sine, tan. Those buttons. Any other buttons? Don't matter. Okay. So when you go to press that button, you slap your hand and you're like, girl, what do I need to be in? It's not hard. It's not hard to know. Because if they give you a degree, it has to be in. Thank you. If they give you a radian, it has to be in. See, so smart. This is why you're an AP. All right. So I go to press this one. I wanted to 3 decimal places. I go to press the sign button, and I do what? No. Stop. Bad. And then I go to mode, and I make sure it's in what? Not just pretty faces, all of you, not just pretty faces. Okay? So make sure you're in what mode? Degree. You're going to have to flip back and forth. It should say at the top if yours is in degrees or radians. Yes. It'll say day. So you're good right now. I think it's mode on yours too.
I don't think it has a
All right, so go sine 30 degrees and then hit enter. One is in scientific notation and one is not. Okay. What is www. Stop asking me questions about your tiny little calculator.com. Okay. So you just need a degree. Alex, do you know what I'm talking about?
Yes.
Okay. Sine of 30 degrees is what, people? 0.500. If it says to 3 decimal places. Okay. Cos pi over 6. So now if I immediately go cos pi over 6, it's going to give me the right answer. No. Pi over 6 is in what? Radians. So I go to press cos button and I'm like, no, girl, no. Go change your mode. Because you in degrees. We just did this last question in degrees. Don't do that. That'd be dumb. So you guys, the good thing about the diploma is everyone's like, it's tricky. They're out to get you. They're not. Because they often don't put an answer to you having it in the wrong mode. Like that would be a tricky, like that's just a general oops, right? They often won't have the correct answer to you putting it in the wrong mode. They actually make you do math, okay, to get the correct answer, or the incorrect answer, sorry. The correct answer will be in the right mode, and then the incorrect answers will be you doing math wrong, not moving in the wrong mode. So, unless it's numeric response and you just think you're rocking it, and you just write it down here. No help for you, okay? So cos of pi over 6, what do we get? 0.6. Okay, this is where your formula sheet comes in handy. Your calculator has a sine, cos, and tan button, even though Brady wants it to have more. It doesn't. It has a sine, cos, and tan. All right? This one, however, says cosecant. We haven't really talked about cosecant yet. However, on your formula sheet, it does give it to you. Up here, if you look, it says tan is sine over cos, or cotan is 1 over tan. We know we have the button sine, cos, and tan. Do we agree? Those are the 3 buttons on our calculator. They're sine, cos, and tan. Yes? This one says cosecant theta equals what? 1 divided by sine of that angle. Correct? We have a sine button, so we can do that. This equals 1 divided by sine of that angle. What mode do I need to be in? Radian, because there's not a degree symbol. So type it in, 1 divided by sine of 1.57 in radian mode. One point zero zero zero. Okay, cotan. You have two options. One is easier. There are two options because the buttons you have are cos, sine, and tan. Correct. So you could use the cotan and do cos theta divided by sine theta. So you would go cos of 70 degrees over sine of 70 degrees, making sure you're in degree mode. Or you can use the easier one, cotan equals 1 over tan. Both will get you the exact same answer, as long as you're in degree mode. So I can type this in as 1 over 10. Now the reason why I have to do that is I don't have a cotan button. So if ever you're like, man, I don't remember how to type this in, be like, hey, I have a formula sheet they gave me. It's got numerous trigonometry things on it. Let's look at it. Okay? The whole entire right-hand side is trigonometry. So I got 0.364. All right. I want you guys to come and grab a homework booklet.